and record. Okay, so please make sure that you guys are helping me out, and I'm probably going to eat a little bit while we're doing this, so I apologize that I'm doing that because that's super, super unprofessional. So, sorry. So we're going to start with number 4 on the 2000, I said 2015, right? Again, completely unorganized. I apologize. And we're just going to look at this. It says a box with an open top will be constructed, and we'll do as much as we can in this little time. Once we're finished, we're finished. If you want more, just yell at me and let me know, okay? A piece of cardboard is 8 inches wide and 12 inches long. The box will be constructed by cutting out equal sides of equal squares of side X at each corner and then folding along the sides. So this is what it's saying. You have a rectangular piece of cardboard, and what they're going to do is cut out the corners, and then they're going to fold up the side of the box. And I usually do a good visual of this when you're in class. I will try to do one right now real fast. So like if I take my Post-it note, I'll do like one side of it, and I tear off the corners, then they fold up the sides to make like the side of the box. If you guys can kind of see that, I don't know if you, so that's what they're doing. And they're doing all 4 corners so that you have a side, and then they'll match up to make that box. So you would have a box when you folded them all up. All right, so we're going to take those off. So what it said was it was 8 inches wide and 12 inches long. So it was 8 inches wide and 12 inches long, but we cut off square pieces that were X's. So that means we cut them. So the new length right here without this is 12 minus, I cut 2 X's out. The new width right here is 8, and I cut 2 X's out. So then it says, what's the function for the domain, the entire domain for the function of the volume? So remember, volume of a box is length times width times height. So we know that the new length is 12 minus 2x. The new width is 8 minus 2x. And remember, we cut out, so if you look at my box right here, we cut out x on each side. So the height of this box, like top to bottom, if I set it on its bottom, will be x. So your height is x units. We don't have to multiply that together. We're just going to put it in our calculator because it asks for domain. And remember, domain is your x values. So I'm going to go ahead and put it in this one. I'm sorry for the glare. I'll try to turn it up and fix it. All right. So we had 12 minus 2x, 8 minus 2x, and just x. And when I graph that, it'll take just a second. You guys see the blue line. So what you're seeing right here is, if I zoom out, you don't need to, there's no point in zooming out on this question, but I want to show you anyway. It's what it does is it'll go up, and then it'll reach a maximum point and come back down, and then it has this minimum, and then it goes back up again. So this area right here, where it starts at 0, it goes up, and it comes back down. That's the volume of the box. What happens here is the box runs over. So like if I were pouring liquid into it, this is the volume of the box that's obtainable. This one is when it starts pouring over, and then it becomes bigger, if that makes sense. Okay, so all we're looking at, that was not what I wanted to do. I want to do zoom 6. I did zoom 9. So give me just a second. All I want to look at is the first part, like how far across X does it go before it goes negative again. So just the positive values. So on the X-axis, it goes from, and you guys can trace it if you want to, it goes from 0 and then over here to 4. So your values are 0 to 4. Okay, and again, we just want where it's coming into the box, this is overflow. So we don't want any of that overflow. All right, let's see what we got next. If we look at number 6, it asks which function goes positive infinity most quickly as x increases. That's always going to be exponential because exponentially grows way faster than anything else. Zoom in. Okay, okay. Sorry, guys. All right. So again, exponential moves quicker than any of those other ones. Let's flip through. Diameter of a circle is 8 centimeters. The central angle of the circle intercepts an arc of 12 centimeters. What is the radian measure? So remember, we were talking about radians and degrees the other day with our unit circle. So we have a circle. It says the diameter of that circle is 8. A central angle of the circle, that means it comes from the center, intercepts the arc of 12 centimeters. Okay, remember 12 centimeters is a length. It's not a measure. Measure would be degrees. So this is arc length. So remember to find that, we do degree over 360 equals arc length over, and what goes down here if it's part of the outside? What formula goes down there for arc length? Oh, sorry. Y'all might have been talking and I might have had the volume down. So if somebody was talking, I didn't hear it.
12 over 360.
What formula goes here? You guys remember?
Pi r squared.
Okay. So pi r squared is what formula? What is that for? What is pi r squared?
The area of a circle.
Area. Okay. So this, remember I showed you the other one the other day. If it asked you about the pizza slice, that's part of the whole circle. That would be pi r squared. And that one's actually arc measure. This one is, or area of a sector. This one is arc length. So it's just a piece of the outside. So what is the outside of the circle called? The distance outside of the circle.
Circumference.
Yes, and that is either pi times diameter, or you can do pi 2r or 2 pi r, whatever you guys have ever known. I just do pi times diameter since I have the diameter. So we're looking for the degree, but we want to put it in radians in a minute. We're not going to do it yet, but we're going to do it in a minute. So we're going to use x for our degree. Our arc length was 12, and then our diameter was 8. So then we're going to cross multiply. When you cross multiply, if you want to do the pi, you can. It's up to you, whatever you want. But I don't typically put it in there. So I do 8 pi equals, and then 360 times 12 is 4320. We divide by 8 pi. I forgot my x in there, so I squeezed it in. Again, I don't use the pi because if I'm turning it to radians, I need to remember what my formula is. So this actually gives me 540 over pi. And the reason this helps me is because I know that I want my pi to cancel out. So I need one on the top. And then we divide by 180. So these cancel. And then in our calculator, 540 divided by 180 is 3. So your answer is 3. Okay, so don't forget how to convert radians into degrees. All right, let's see what else we got. Again, stop me if you have questions. On this one, we have a 60-degree angle, we have a 90-degree angle, That means this one is 30. If you can remember your 30, 60, 90 rules from Math 2, then you can use those. I used to know them a long time ago. I don't remember them anymore. And instead of looking them up, I just use my trig functions. So I'm better with that. So your trig functions that you used, SOHCAHTOA, I don't know what else you say. There's lots of sayings for that. But what I need to find is this x. So to be able to find the x, I need a bunch of other measures. So the first measure that I'm going to find is going to be this one. The reason I'm going to do that is if I can find this one and that one, then I can use Pythagorean theorem to finish this out. Okay. So that's the reason I want to start with this one. This one works with both triangles. So that's the reason I started with this one. And then I'm going to find this side right here. Okay. Because then I have the 10 and then all of that. So check this out. The way we do this to find x, you can use either the 60 or the 30. I used the 60. The reason I use sine is because I have my opposite and my hypotenuse. Okay, so x is opposite and 10 is your hypotenuse. So x over 10. Don't forget to put your calculator in degree mode. So you multiply by 10. And you get x equals 8.66. Then I found this side so that I could just have a right triangle right here. So I'm going to find this side and then I'll figure out what this side is. So the reason I do that, I don't know, yeah, I have a highlighter, is because the 60 also works with the big triangle. So I wanted to highlight it so you could see it. All right. So if we have 60 and we want to know that one is the opposite and 10 is the adjacent because this long side would be the hypotenuse. So opposite and adjacent is tangent. So this time we're going to do tan 60. Opposite is y. Adjacent is 10. So we do 10 tan 60. Then we get y equals 17.32. Now I can work with just this triangle because I have two sides and I can find the third one using Pythagorean theorem. This one's probably one of the lengthiest. I don't think it's hard, but it's lengthy. Okay. So we're going to do x squared plus 8.6 squared because this is not your hypotenuse. Remember, this is your right angle. So this one is your hypotenuse. So x squared plus 8.66 squared equals 17.32 squared. I'm pretty lazy. I told you guys that. I'm going to try to get everything on the calculator on the screen. So I would do 17.32 squared minus 8.66 squared. And I get 224. So I get x squared equals 224.9868. I'm going to take the square root of that. And 14.999 is approximately what? 15. So again, if there's a better way to do it, you can do that using your 30, 60, 90 rules. There probably are. It just, 30, 60, 90 rules would make this a whole bunch easier. So if you would find your 30, 60, 90 rules, you could see that this one was 60 and this one was 30. So you can use this side. You could get that 17.32 and then get the other side. I don't know. You choose whatever you want to. I'm just showing you the way that I did it. Okay. We did number 10. Number 11, not a hard problem. Again, one of those kind of lengthy problems. So it said a farmer wants to buy between 90 and 100 acres of land. He's interested in a rectangular piece of land that is 1,500 yards long. Be careful about that. 1,500 yards long and 300 yards wide. This piece of land is being sold as one complete unit for $87,000. If the farmer does not want to spend more than $900 an acre, does the land meet all of his requirements? So read this. 1 acre equals 43,560 feet squared. Feet squared, so you got to be careful. So the first thing that you want to do is see how big this land is, because he only wants between 90 and 100 acres. So let's figure that out first. So we got to figure out square footage, not square yards, okay? So square footage, how many feet are in a yard?
3.
3. So I'm going to multiply this by 3. And I have it wrote down, so I don't have to do it in my calculator, but you guys can do it in your calculator if you want to. You get 4,500 feet. And then you're going to do 300 times 3. And you get 900 feet. So how do you get square footage?
Multiply 'em.
Multiply them together. So I'm going to do that. 4,500 times 900 gives us 405 and 4 zeros. 4,050,000. Okay. But it doesn't want square footage. What does he want? 90 to 100 acres. So we have a conversion. 1 acre is 43,560 feet. So how do I get this into acres?
Divide.
Divide it.
And when I divide that, I get 92.98. Does that meet his requirement? Let me say that one more time. Does that meet one of his requirements?
Yes.
Yes. He's got between 90 and 100 acres of land. The next thing we want to check is if that it's worth the price that he wants to pay. He doesn't want to spend more than $900 an acre. So right now he has 87,000 that it's being sold for, 92.98 acres. How do I figure out 1 acre price?
Divide them.
So 87,000 divided by 92.98 is going to give us 935.69. Does it meet those requirements?
No.
No. So yes, it's the right size. No, it's not the right price. So we know it's not a yes, he's not going to buy it. No, the price is low enough, but there's too much land. The price is low enough, but there's not enough land. Or the amount of land satisfies, but the price is too high. Which one is it?
D.
So again, not a hard problem, just takes a few minutes. All right, so let's look at these real fast. Number 13, we had a couple of these where you were talking about mean and standard deviation and stuff like that. So you learned this in Math 1. If you take AP Stats at some point, you'll learn it again. Not a big deal. So you have this normal curve, and in the middle of the normal curve is your mean. And then it's typically 3 standard deviations above. In AP Stats, we only go 3 standard deviations above or below. But it could be more, but that's usually the range that they're looking at. Okay. So this is 1 standard deviation above, so it's a +1, 2 above, 3 above. This would be 1 below, so a -1, -2, and -3. So it says in a set of test scores that are normally distributed, a test score of 76 is 3 standard deviations below the mean. So this is 76, this one right here is 76. A score of 88 is 1 above. All right, so what you need to understand is all these bars are exactly the same width. That's the standard deviation. So it wants to know what the mean of the data is. So what you want to do is find the spread between these two. So what is 88 minus 76?
12.
12. How many bars is between there?
3.
How many marks did I make?
4.
4, which does give us a standard deviation of 3. So you're good with that. So then how would I figure out the mean? All you do is take whatever's closest. You can take the 88, you can do the 76, it doesn't matter. If you take the 88, you're going backwards 1 standard deviation. So we said our standard deviation was 3. So 88 minus 3 is 85. If you did it the other way, 76 plus 3 plus 3 plus 3. It doesn't matter. It's all going to come out the same way. Okay. We did 14. Look at 16. What's the approximate length of the arc subtended by the angle 4 pi over 3 radians on a circle with a radius of 6? Okay. Let me see what I got. All right, I didn't use the radius at all. Yeah, I did. Yeah, I did. We're going to change this to degrees because it asks about the length of the arc. So we're going to go back to the arc length. So that's why I marked that out. We weren't even ready yet. So remember our formula is degree over 360 equals the arc length over what was that formula that went down there?
Circumference.
Mm-hmm. So either pi times diameter or 2 pi r, whichever one you'd like to use. We don't know our degree because we need to change this to degrees. So remember, we have 4 pi over 3. To change it to degrees or to change it back and forth, we need to get rid of the pi. So if the pi is on top, we put the pi on the bottom, and then 180 fills the other slot. Okay, so that way your pi's cancel out. You do 4 times 180 divided by 3, and you get that your degree is 240. Okay, so 240 over 360. We're looking for the arc length over pi, but we have a radius of 6 meters. So the diameter would be 12. This one did not leave it in terms of pi, but I like to leave it in terms of pi till I get to the end so it's not as much work. So I'm going to cross multiply. I get 360x equals 240 times 12, which is 2880 pi. Then I'm going to divide by 360. And again, all this does, leaving it in pi, is keeping you from having fractions and decimals in there. So when we divide 2880 by 360, we get 8 pi. And then now, I'm going to multiply by pi, which gives me 25.13. And then we're done. Okay. We're going to flip it. The length of a rectangular prism is 4 square root 3 units. The height is 3 square root 6 units. If the volume is irrational, what did I tell you irrational meant?
Decimals or fractions.
Yep, decimals, ugly numbers. Which could be the measure of the width. So how do we find the volume of a rectangular prism? Volume is?
Length times width times height.
Thank y'all. I really do appreciate everybody that is answering because I do have one class that they just look at me, I guess. They don't ever answer. So I do appreciate all of you answering at any point in time that you answer. So we know that the length is 4 square root 3. The height is 3 square root 6. And we want to know what width makes it irrational. So you're literally just plugging in your answers, okay? So 4 square root 3, 3 square root 6. And then we're going to start with 2 square root 50. And we got a whole number, but we wanted, 720. We got a whole number, but we wanted a decimal, so we didn't want that one. I just hit second and enter, so it brings it up again, and I'll type over that 2 and 50. So that way I don't have to type everything. Second enter is what I did. So I'm going to change it to 4 square root 12, and I'm going to hit enter, and there's my decimal. I'm going to show you the other ones just so you can see that I always check them. Like when I'm doing this, I always check to make sure I didn't type anything in stupid. So I'm going to go ahead and do the last one, 7 square root 18, because that's what the kind of thing I have in. It's a whole number. And then the other one is 5. And then I just delete the 1 square root 8, which is 720, which is also a whole number. So again, I always check once I'm done to make sure that those other two don't make any sense at all. Okay. Any questions on 17? All right. I think that is all of that packet. You look at your other one. Sorry, it's getting reorganized. I apologize, y'all. I really do. I don't know which ones we have and haven't done. We did 21. I remember doing it. I think this is my answer key one. One, 2, 3. All right, look at number 4. Look at number 4 on the other packet. So it says Samantha invested $10,000 in each of 2 different financial plans in 2013. The predicted value of each plan is modeled below. Do you guys remember your formula for compounded continuously? Compounded continuously. Check it out. Let me find it for you. Oh, I don't want that. Okay. You guys remember that formula right there? PE to RT. I think we did that like one little day. It wasn't a big day or anything like that. So compounded continuously, I call it the PERT formula. And remember, E is just like pi, it's just a number. And then plan N gave you the formula. So let's look at plan M for a minute. P is your initial value. She invested 10,000 in both of them. So your initial value is 10,000. So this would be the hard part about this one. We had E. Our rate was make it a decimal. So move 2 decimal places. 0.075, and we don't know the T. And then we have plan N. That's up there, that 5x cubed, It says plan N has a greater predicted value than plan M during which years, okay? So these are financial plans in 2013. It's the number of years after 2013. So you can plug those numbers in if you'd like. I usually just look at them. We can plug them in. Hold on, let me see. I'm gonna try to do it Desmos. 10,000. I don't see the little e, but I think I can put it in. E to the 0.075. I gotta put a parenthesis, sorry, 0.075 x. And then I'm gonna go back and put y equals in. Y'all, I'm just trying this, hoping it's gonna work the way that I want it to, okay? Y equals 5x to the third minus 50x squared plus 4x plus 10,000. I'm gonna drop this down. And there they are. So it says Plan N has a greater predicted value than Plan M during which years? So the red one is M, the blue one is N. So our years, if we start, our first one was 2014, so it'd be like 1. And then you can look between the other one. What would 2041 be? How could you find that?
You subtract them.
Mm-hmm. So that subtraction gives you that 28. So I'm gonna look in between there. This might take a while. I don't really like this. Nope, I don't like this way at all. It's too hard to manipulate. All right, ignore that I told you to do it this way. I apologize. I was trying to make it easier and I think I'm making it harder. Let's go back. Back to this. All right, let's just plug in from 1 to, what do we have? 28. So Plan N has a greater predicted value than Plan M during which years? Okay, so if we plug in 1 to 28, I don't know how, trying to figure out how to do it where you guys can see it. Let me see if I can manipulate it on here. This might be something that I have to do a little bit later. And then 5x to the third. Nope, nope, nope. I'm going to change my window on X from 1 to 28. Let's see what happens. I think it's going to change it again. I'm going to fit it and then I'm going to try again. All right, the blue one is M. You guys see, sorry, you don't see. You see where they cross right here? That's where, sorry. This is where the red one is actually going to go over the blue and be bigger. So this is the point that we really need to look at. But I want to show you between 1 and 28. So that's between 1 and 28. Let's change it for the next one. What would 28 be? So 2028 minus 2013 is 7. And then 2055 minus 2013 is 42. Between 7 and 42. So I'm going to change my window between 7 and 42. And let's see what kind of graph I have. There's your blue one. We want the red one to be on top of the blue one. It's still not quite there, right? So 2042, this is the best way to show you. 2042 minus 2013 and 2073 minus 2013 is 29 to 60. So I'm going to change my window, 29 to 60. and hope it works. I think my calculator's tired. I'll show you. I'll show you on the table. I don't know why it's not graphing it now. It's graphed all three of those. I really, really apologize. All right, let's go down to 29 to 60 and see if the blue is bigger. So all this other time, the blue has been bigger, 1 to 28, 7 to 42. So let's get down to 29. And if you look, what happened at 29? What about the blue compared to the red? Remember, this other times the blue's been, all these other ones that we've had, the blue's been lower. What happened at 29? I mean, the blue's been bigger, sorry. Blue's been bigger. What happened at 29? Don't let me lose you. Look at the values of blue compared to the values of red. Which one's littler?
The blue one.
Yeah, so that's the one that we want. So it's going to be C. This one said Plan M never has a greater value, and you know that's not the case. So let me kind of break this down one more time. What you have are two graphs that kind of look like this, and then all of a sudden, a long time away, they'll cross. What we saw from 1 to 28 was like right here. So from 1 to 28, the blue was still above. From 7 to 42, the blue was still above. But then 29 to 60 was this area right here where the red actually went above. So that's when M was bigger. And it's just a graphing and manipulating your graph. And this is what they like to do, is they like to give you big numbers where you have to really mess up your graph a lot. Okay. So I apologize. That one was kind of weird, but it's just manipulating your calculator. Let's see if there's anything else. All right. 17 is another mean standard deviation. 17. Going to draw that same curve. Mean. 3 standard deviations. So remember your means in the middle. It says a town has 685 households. The number of people per household is normally distributed with a mean of 3.67 and a standard deviation of 0.34. How many households have between 299 and 4.01 people? All right, so looking at this one, you have a mean of 3.67. Remember, each width of these bars is a standard deviation. So one standard deviation above 3.67 plus 0.34, one standard deviation above would be 4.01. If you look, that's the number we were talking about. That's the first one. 299 would be below it. So we would do 3.67 minus a standard deviation, which is 3.33. And again, this is a math 1 concept. This is not a math 3 concept, okay? And this one is 2.99, which was the other one that we needed. So it says a town has 685 households. The number of people per household is normally distributed with a mean of this and this and this. It wants to know how many households are between here. So back in math 1, you learned that these two added together was 68% of your data. And again, that's math 1. That was something that you should have had ingrained into you, and you probably forgot in math 2, but it's okay. And then this one is 13.5 on either side. 13, I think I put the point in the wrong way. Sorry, 13.5. And then both of these together are 2.5. Okay, all of that will add up to 100. All we're really concerned about are these right here. We're looking at the 3 percentages. So we're going to add them up. 34 plus 34 plus 13.5. So when we add that up, we get 81.5% of the data. 0.5%, sorry, I'm not writing very well today. 0.5% of households fall within that range. So how do I find 81.5% of 685?
You can multiply the 0.815 by the 685.
Perfect. When you multiply that, both of you were perfectly fine. You're going to get 558.2, which is approximately 558. Okay. Any questions on that one? Watch those percentages. Okay, watch those percentages. Okay. Move it around. We did inverse. Don't forget inverse is just switching X and Y and solving for Y. You'll probably have some of those on there. And that's it. That's all the review that I have for you guys. So I'm gonna stop sharing. Do you guys have any questions for me? I know that's a whirlwind and I know it's been a crazy semester, but I just want you to do your best. And like I said, when you take this test tomorrow, exhaust every option that you have. Start with that Desmos and see if you can do it on Desmos. Remember, if it's equal or equivalent, you can do y equals the left side and then y equals the right side and find the equation. Sine and cosine, all that is in there. Don't try to do the sine and cosine on your calculator because it's too hard. What else? What do y'all need from me? What do you feel? Nothing? You feel like you're ready to go? Anybody?
Yeah, I feel fine.
Okay, I appreciate that, Evan. Thank you. Make sure tomorrow that your Chromebooks are at 100%. They took people's Chromebooks today because they weren't at 100% and gave them one that was 100%, not in a bad way. They just wanted to make sure that it didn't die in the middle of the exam. So if you want to bring your own calculator, you can. If it dies for some reason, they'll have one in the room for you. So don't freak out about that either. Everything can be taken care of. You'll get scrap paper, graph paper. Remember, you'll get Desmos and a handheld calculator. So you've got everything that you need. I'll send out an email with the rooms that you're supposed to go to in just a few minutes so that you guys will have that as well. Can y'all think of any other questions that you might have? Today lasted, I mean, it was a long day. So I had one that took some extra time and I finished at 2 o'clock. But I mean, that's what I was trying to tell you guys is that they had planned to finish it at 1. Everything was going to be good to go by 1. And I have not even eaten lunch yet. So just be prepared for all of that. Can you think of anything else? If not, you're good to go. I've appreciated everything y'all have done this semester. I've loved having y'all in this weird situation. It's been amazing. If you need anything, ask me. If you go to your next class and you need help, just ask me. And just good luck tomorrow. Have a good time and don't freak out about it. You're going to be fine. Okay. All right. Have a good day, y'all.
I have a question, Miss Jones.
Question away, Lily.
On number 9 in the 2015 packet.
Did I screw it up?
No, it's not
Okay.
anything that you did. I just like last year in math 2, I didn't really like I had it during the quarantine section.
Yeah, that's fun.
So I didn't really understand like the sine and the tangent and that type of thing. So
Okay.
I was wondering if you could explain the 60, 30, 90 way. Because I didn't really understand the way you just did it.
Okay, let me see. Give me just a second. Everything's coming up crazy. I'm trying to get it up. I'm going to share with you so you can visually see it so that you're not super stressed about it, if that makes sense. Sometimes I'm a more visual person than I am. Okay, so on my screen, these were your 30, 60, 90 rules, and these are your 45, 45, 90. So what it says is that the angle across from the 30 is X, the hypotenuse is 2X, and the longer leg is X square root of 3, okay? So if we go back to the other one, the longer leg, so this is your 30, 60, 90, this is your short leg, and I'm talking about the biggest one, is gonna be your short leg square root of 3, okay? So if I put that in my calculator, you can see that I get 17.32. So that's how quick this turned out to be. And now I can do Pythagorean theorem. But the problem is this little gap right here. So I can also do it this way. So here, if I go back to my 30, 60, 90 rules, it says that my hypotenuse is 2 times the length of my short leg. 2 times the length of my short leg. So this is my hypotenuse, which is 2 times the length of the short leg. So this one would be 5. All right, so let me get a clean sheet and I'll show you without having all this crazy mess on it. Okay.
Teachers, this is just a quick reminder that if you are giving an exam tomorrow in your classroom, please, before you leave today, if you will look at the testing schedule and see how many students you are supposed to be testing in your room, and go ahead and arrange your desk and put names of the students that are to be in your room on the desk. And that way, if anything were to happen and you were not able to make it in the morning, everything would be ready for us to roll.
We're going to ignore
Thank
this,
you, and I hope everyone
this
has a
line right
wonderful
here for just a minute, okay? Ignore it for a minute. So here's your 30, 60, 90. This is your short leg. So the rule says your short leg is X. Your hypotenuse is 2X. And your long leg is X square root of 3, okay? So this is my short leg. My hypotenuse is 2 times that. So this is 20. You see that?
Yeah.
Ignoring this. Okay, so now what I'm going to do is ignore this half, all right? So I have a 30, 60, 90 again. My hypotenuse is 2 times, I'm right and left-handed, so hold on, this will be pretty. 2 times my short leg. So divide that by 2 and I'll get 5. Watch this now. How do I get this X? I have the whole thing is 20. This little piece is 5. So how do I get this piece?
You would subtract it.
That's where you get your 15 from.
Okay.
So 30, 60, 90 rules make it a lot easier, but a lot of people don't remember their 30, 60, 90 rules.
Okay. So like I should just memorize the different sides.
You can. If you had a 45, 45, 90, your 45s are going to have the same, and I'll show you again on my thing. Your 45s will have the same, and your hypotenuse is X square root 2. So those are good ones to do. I don't think they put them in the curriculum anymore, though. They might be in the honors curriculum, but I don't think they're in the regular Math 2 curriculum, 30, 60, 90 rules. So,
Okay.
all right. Any more questions?
I think there was one more. In the other packet, I think it was like the other one that we did, number 16. You explained it yesterday, but I was a little confused on it.
15, 16. Okay. So what it says, I'm trying to find an empty back of the packet so I can write on it. William put the tip of his pencil. Let me share so you can see. William put the tip of his pencil on the outer edge of the graph of the unit circle at the point 0, -1. So remember, our unit circle is just on a regular coordinate plane, and 0, -1 would be right here. Okay, so he's starting there. He moved his pencil tip through an angle of 4 pi over 3 radians. So we need to change that to degrees. That's how I look at it a little bit. I can do degrees of a circle better than I can do radians. So that's why I change it to degrees, okay? In the counterclockwise direction along the edge of the circle. So I'm going to go ahead and change this to degrees. So remember to change to degrees. I have a pi on top. So I want to get that to cancel out. So I put a pi on the bottom and I do 180. So your pi's cancel out. 4 times 180 divided by 3 is 240. So I'm going 240 degrees. Are you good so far?
Yeah.
Okay. So when I draw my circle, when I get to this point, how far have I gone?
Is it 180?
Yes, ma'am. It's half that circle. So this is 180 degrees. So what I did was I did 240 minus 180, and I got 60 degrees was left. Okay. You see that?
Yeah.
So right here, this was 60 degrees left. All right. So this is not 180 degrees. Remember, we start at 0. This one is 90. This one is actually 180, right? So we need to figure out what this degree actually is. So I went 60 degrees from my 90 degree. So I did 90 plus 60, which is 150 degrees. So that actual angle is 150. Then all I have to do is turn it back into radians. So 150. To turn it into radians, I have to have a pi on the top because it's 4 pi over 3, 2 pi over 3, something pi. So the pi has to be on top. And then I just put it in my calculator, 150 over 180. Math, enter, because it was a decimal, gives me 5 over 6. And I just have to have a pi. And that's it.
Okay. I think that makes more sense now.
All right. Can you think of anything else?
No, I think that was all.
All right. Well, I'm gonna let you get off here. My phone's ringing like crazy. All right, girl. I'll see you. Good luck tomorrow.
All right. Thank you.
Bye.